Ever looked at the simplest object in your kitchen and wondered how it came to be? You might be holding centuries of engineering in your hand, and wood that burns turned into something you write with, sand made to hold water without leaking. This video takes you through 10 everyday things that go through fire, force, and precision to become what you use without thinking. The transformations look effortless until you see the raw power behind them. Number 1. How pencils are made from trees to graphite. A forest once stood where your pencil began. Straight cedar trees cut into clean logs meet saws that slice them into thin, perfect slats. The process feels like taming nature into order. Then comes the paradox. Wood that burns easily is built to hold words forever. Each slat gets fine grooves, waiting for the next piece. A narrow core made from graphite blended with clay. Heat hardens it into steady darkness. Two grooved boards meet, sealed and pressed until no seam remains. Machines trim, shape, and smooth each stick until it balances strength and glide. Cedar's softness meets engineered precision. Grain, density, and pressure align so it won't splinter or snap when turned in your hand. In the end, every pencil is nature compressed. Graphite and fire restrained in cedar, waiting to mark thought itself. From flame's control comes glass next. Number 2. How glass bottles are formed with liquid fire. Molten sand glows white hot, thick as honey inside the furnace. At over 1,700 degrees Celsius, the sand loses its crystals and turns to liquid fire. This isn't decoration, it's the start of purity from dust. What once looked like dirt becomes something that can hold light itself. The molten stream drops into molds. This machine blows and presses pockets of air inside, shaping precise bottles in moments. Heat rules every motion here, but order wins. Then, each bottle enters the annealing line, cooling slowly so that invisible stress won't crack its form later. That steady cooling locks strength into transparency. Inside every finished bottle is the echo of that flame, trapped, tamed, and clear. What began as chaos under fire ends as calm clarity in your hand. Next comes texture, where roughness itself becomes part of the design. Number 3. How denim jeans get their signature faded look. Cotton starts as soft white fluff pulled from tall green stalks, crude and uneven. Those bare fibers twist into yarn, later dipped in indigo vats that cling only to the surface. The dye stays shallow so wear can reveal the white beneath. Nothing yet looks like the faded blue we know. When woven into denim, the cloth turns stiff and dense. To break it, factories load jeans into giant drums with pumice stones or blast them with sand under pressure. The abrasion scuffs away the outer dye patch by patch. This erosion becomes beauty, texture drawn by friction, comfort built through wear before you even touch it. What began in dirt becomes soft color and surface memory. From the feel of fabric shaped by resistance, and we move to precision built for flavor. The world of perfect crispness. Number 4. How potato chips are mass-produced with precision. A potato rises from the soil, rough and crooked, coated in earth. It rolls through washers, shedding its skin of dirt before metal blades meet it. This machine spins, slicing hundreds of whisper-thin sheets every minute. Each slice nearly identical, each edge so exact that no two chips miss a beat in the fryer. The slices fall through water to rinse away starch, staying separate and ready. Then comes the oil, a golden flow held steady by exact heat. Chips tumble through in seconds, changing color and sound at once. Above the line, sensors watch for flaws, removing anything too dark or light. By the end, random roots have become uniform sound bites of crunch, each curve measured and repeatable. It's chaos carved into order, preparing the way for another controlled indulgence. Sweet precision shaped in cocoa. Number 5. How chocolate bars are created from raw cocoa beans. Thick pods hang from shaded trees, their shells hiding pulp so sweet it sticks to your hands. Inside are cocoa beans, pale and bitter. Cracked open, they taste nothing like chocolate, more like earth and acid. Yet this is where the story starts. The beans ferment in heaps, heat building as microbes unlock new flavor notes. Roasting dries them, deepens aroma, and loosens each shell. Ground until liquid, the mix becomes chocolate liquor, dense, rich, and raw. Presses divide it into cocoa butter and dark solids. Conching takes over next, endless mixing and warmth polishing flavor and texture. Each particle shrinks, coated with fat until smooth. Controlled heat keeps the cocoa butter aligned, giving that clear snap and melt. From heat and motion, bittersweet chaos turns to silk. Now, transformation shifts from luxury to renewal, old paper learning to live again. Number 6. How paper is recycled into fresh new sheets. Discarded sheets pile up, crumpled notes, old newsprint, yesterday's lists. All look finished, but the story restarts here. How does paper already processed begin again? This is how. Machines shred the piles into fragments. Water and chemicals turn them into pulp, a wet mix where ink still hides. De-inking removes it. Air bubbles cling to pigment, lifting color to the surface to be skimmed away. Further filtering clear staples and plastic traces. Now fiber length and water chemistry decide the outcome. Shortened fibers weaken new sheets, while water balance helps them bond strong and bright. The cleaner the mix, the smoother the roll. Pressed and dried, the pulp becomes long, flawless reels. The old dissolves, yet reforms as crisp white space ready for new words. From reclaimed fiber, the next transformation presses metal into motion. Dr. Number 7. How aluminum cans are pressed and shaped in seconds. Gray metal sheets slide from bauxite dust and rock, dull at first glance yet full of promise. These sheets feed into presses that cut perfect circles, blanks ready for transformation. In a flash, deep drawing begins. A punch drives each disc into a mold, stretching and thinning it into a flawless cylinder before it can cool. The move happens in fractions of a second, a blur of speed and shape. Every wall's thickness matches within human hair precision. This stability comes from alloy design and grain alignment, preventing the fragile shell from tearing. The metal yields, but never breaks. Moments later, what was raw crust becomes smooth containment, light enough to crush by hand, yet strong enough to hold pressure and fizz. It's liquid lightning trapped in aluminum, born from earth and speed alike, leading next to pressure of a gentler kind. Number 8. How toothpaste is mixed and filled without air bubbles. Thick white swirls coil inside tall steel vessels, blending minerals with mint oils until the mix turns satin smooth. The paste moves but barely flows, heavy like clay, yet expected to glide on a brush. It must stay airtight because even the smallest bubble breaks its perfect texture. Vacuum mixers pull the air away, folding the paste under pressure until nothing interrupts its sheen. Color striping systems thread tinted gels through narrow valves, painting ribbons inside the flow with split-second timing. Tube fillers then seal each dose without trapping a flicker of air, keeping every squeeze consistent. Sensors watch flow and speed, syncing color and pressure so each pattern lands in the same place, batch after batch. What began as soft minerals becomes a clean, precise stream ready for daily ritual, smooth motion giving way to molded strength next. Number 9. How rubber tires are built layer by layer. Raw latex drips from trees as sticky, shapeless sap. It clings to every surface, soft and unruly. On its own, it's useless. Too stretchy to hold form, too weak to carry weight. But inside the factory, chemistry, pressure, and heat rewrite its identity. Robotic arms layer sheets of rubber with fabric plies and steel belts, building strength from the inside out. Thick tread patterns press in under heavy molds, defining every groove's direction. Then the tire enters vulcanization, heat mixing with sulfur to cross-link rubber chains, locking flexibility with toughness in one move. When the molds open, the black ring holds memory of both fluid and furnace. Sap has become grip, elasticity turned into stability. It's living material engineered for road and revolution, and from this raw strength, the next form brings a cleaner transformation. Number 10. How soap bars are molded, stamped, and polished. Soap begins with two simple ingredients, fat and ash. When mixed with lye, the reaction of saponification turns grease into a thick base of soap and glycerol. It still looks crude, loaded with water that must later be dried away. Spray dryers or air systems pull that moisture out until a dense, solid base remains. The paste runs through an extruder, forced through a die that shapes it into a smooth log. Sharp cutters slice perfect bars that travel to stamping machines, pressing brand emblems or textures into each one. Mechanical polishers glide over the surface, trimming rough edges, giving the bar a glossy sheen. What started as oil and alkali emerges as a clean rectangle ready for daily use. Dirt literally becomes the tool of cleanliness, leading naturally into a final reflection on transformation and design. Every familiar object hides a story of heat, pressure, and patience. The same minerals, fibers, and oils found in nature become the tools and comforts of daily life. Each one traces a violent yet elegant path from dust to design. Technology moves forward, but the rhythm stays the same. Extract, shape, refine, repeat. Look around your room and see the quiet choreography of manufacturing at work. Every smooth surface and clean edge started as something wild. That will be all for today. Subscribe to our channel for more transformations that reveal the design behind the everyday, and hit the notification bell.